This is page 18. We're looking at properties of triangles. So if you have any AirPods in, if y'all could take them out, and if you have your cell phone, if you could put it down in your bag so that your focus is up here. We're looking at properties of triangles. And then we're going to apply the properties to solve for missing sides or missing angles of the triangles. So just a reminder that a triangle is a polygon with 3 sides and 3 vertices. You already know that. There are different types of triangles. We've talked about acute, right, and obtuse angles. They also apply for triangles. Acute triangle means all of the angles are less than 90. A right triangle means there is one angle that is a right angle. An obtuse triangle means there's one angle that is greater than 90. Equiangular triangle, what does it sound like it means? Equiangular sounds like equal angles, right? 3 congruent angles. You'll notice they've got marks here, here, and here. What's nice about triangles, however many congruent angles is the same number of congruent sides. Okay? I'm going to say it again. However many congruent angles is the same number of congruent sides. So if you have an equiangular triangle, you have how many congruent angles? 3. So then how many congruent sides would I have? 3. So you can come to an equiangular triangle and you can mark, okay, so all the sides must be equal as well. Which brings me to the word to describe a triangle where you know the sides are equal. It's called an equilateral triangle. Lateral means side. Equilateral, equal sides. So the name of the triangle is literally telling you what's equal. Okay. If you have an equilateral triangle, then how many angles would be equal? Did I hear it? 3. However many congruent sides also matches the congruent angles. They both match, okay? So if you want to make a note, maybe right here, congruent sides matches congruent angles. So however many congruent sides there are, that's how many congruent angles there are, and vice versa. That's a big helpful hint when you're solving some of these problems, okay? Caleb, will you take your AirPod out? Thank you. When we're looking at classifying triangles by sides, right? By sides, we have 3 possibilities. Scaling means none of the sides are congruent. So I could mark this as 1, I could mark this as 2, and I could mark this as 3. And that would indicate none of these sides are equal. That's called a scaling triangle. Isosceles means there's 2 sides equal. Isosceles triangle means there's 2 sides equal. I need you to get used to hearing me say, turn it like a rooftop. When we start practicing the questions with an isosceles triangle, you're going to hear me say, turn it like a rooftop. And what I mean is like the roof of a house. Think of just any standard house that has a roof. The roof looks like an upside down V, right? You with me? Like if you're standing on the side of it and you're looking at the side of the house, the roof looks like this, right? Okay, I want you to think of an isosceles triangle as the roof of a house. I'll come over here and make a note. So for an isosceles triangle, we're going to think of like you've got some house, and then you have the, what? Roof of the house. Wouldn't the roof be equal on the two sides? Wouldn't it look goofy if the roof was not equal? So I want you to think of the roof of a house. Okay? I'm going to say turn it like a rooftop every time. And then in an equilateral triangle, we already talked about how all three sides measure the same. Well, if all three sides measure the same, then what do we know about the angles? If all three sides measure the same, what do you know about the angles? The angles measure the same. What did we learn was the total in the angles of a triangle? What's the total? 180. Who's talking to me? Well, 180. If the angles measure the same and we know they add to 180, do we have enough info to find the measure of the angles? If we know they're the same? Yes? How would I find it? Divided by 3. If they're equal. You got 3 equal angles. They add to 180, right? So I could do 180 divided by 3. And what's the measure that you get? What's 180 divided by 3, y'all? What's 18 divided by 3? 6. Tack a 0 on it. 60. So I want you over here to make a note for equilateral. We usually don't call it an equiangular triangle. It's just like, that's kind of like a mouthful. We usually call it equilateral. But in an equilateral triangle, since this is how I abbreviate the word angles. I draw the angle symbol, and then I put an S. Since the angles are congruent, then they measure, and I'm going to show the math, 180 divided by 3 equals 60 degrees. That's how we got it. So every time you have an equilateral triangle, you secretly know the measure of the angles. Every time. Every day, all day. Doesn't matter if it's a small equilateral triangle. Doesn't matter if it's a big one. It's 60, 60, 60 every day. Okay? So this is a tool, right? Y'all awake? Y'all staying with me? Michaela, Landon, Skylar, staying with me? Y'all wake up, please. So if I have a small one, a medium one, and a big one, go with me. Pretend they match. Congruent, right? Congruent. With me? What type of triangles do I have? They're equilateral. Every single one of them. You just got a small, medium, large, but they're equilateral. If it's equilateral, I can come in here and label the angles. What do they have to be? What's the measure of this angle? Do what? Why? Angle A plus angle B plus angle C has to equal 180. If it's equilateral, it's equiangular, so they have to match. So if they're all equal, I can take 180 and divide it by 3. So this is 60. What's this? What's this? All right, what about this one? What's this? You sure? Trust your gut. You sure? Yeah. What's this? What about that one? Does it matter? This one's small. This one's medium. Does it matter? No. Not at all. Doesn't matter. As soon as I see this to let me know that it's equilateral, then bam, I know 60, 60, 60. every time. What about the big one? Does it change? Nope. 60, 60, 60. Right? Okay, what about if I gave you this? What notes could I take on that? What's congruent? If the angles are congruent, then the sides are congruent. Okay? So these are little like secret pieces of info that you've got to know. Because it's going to help you when you're filling out the problem, like when you're solving the problem. All right? Coming back over here. So that's all the vocab, and the big takeaway was the fact that if you have an equilateral triangle, you're secretly supposed to remember, okay, the angles must be 60. There's one more thing I need to show you, and that's with an isosceles triangle. Let me clear this. When you have an isosceles triangle like that, is that turned like a rooftop? No. So you're going to see me demonstrate with my arms, like from sideways, like turn it like a rooftop. Okay, so that it's upright, and that the left and the right side are the congruent ones. So turned like a rooftop, I'll turn it this way, would be like this, right? Is it turned like a rooftop now? You with me? Yes. Okay. There's a little bit of vocab here. Y'all stay with me. Stay with me, everybody. The vocab is, when you turn it like a rooftop, this is called the base, which makes sense because now it's sitting on the bottom, like it's sitting on the base, right? There's another vocab word associated right here with this angle in the top. That's the pitch of the roof at the very top. It's called a vertex angle. It's called a vertex angle. And then one more vocab word is the sides that are equal are called legs. Okay? So when you take an isosceles triangle and you turn it like a rooftop, it should be sitting on the base, and then the legs should be the left and the right side, the ones that are equal, right? Because theoretically your legs are equal in length, right? Unless you're like my son, who his right foot is bigger than his left foot. When you have an isosceles triangle, this is really important. Hope you're listening. We said however many congruent sides matches congruent angles, right? Where do you think the congruent angles are? If you were to just guess. Yes. Let me change colors. Here's the new part. So we have an isosceles triangle. We've turned it upright so it's like a rooftop. And now we have the legs on the left and the right. Then the base angles are also congruent. That's the new part. Base angles are congruent. Okay? That is a very critical part that you're going to have to use on these practice problems. Let's look at our notes and figure out where we can write this. So we have our isosceles triangle. We turn it like a rooftop. Let's draw another one right here. Let's copy those vocab words. This is the base. This is a leg. This is a leg. This is the vertex angle. And then now, if you have a colored pen, that'd be great. If not, then you could just make it bold with your pencil. But what's important is that you need to mark these base angles congruent. And let's make a note. Base angles are congruent. That is really important. When we start these practice problems, if an isosceles triangle or an equilateral triangle comes up, you're probably going to get lost if you don't remember this critical concept right here, okay? Or or with equilateral, if you don't remember that you know the angles are 60 every time. And it's always 60 on equilateral. Now here, we actually don't know what they measure. You just know they're equal. We don't have a clue what they measure because it all depends on whatever the vertex angle is. But we do know they would be equal. Okay? All right, so let's start practicing with these concepts. Let's practice these concepts. Okay, match the triangle description with the most specific name. So take a second. You can lightly trace with your pencil to connect like one to whichever one you think it is, and then we'll go over the answers. But I would love for you to try this on your own, okay? It's kind of like in a sport. If I've got a new player on the team, I'm not going to just put them in a position. I want to see their skills first, right? So please try it on your own. Do it lightly in pencil if you're worried it's wrong. You're reading the info that you would know on the triangle, and then you're finding the vocab word that would match that triangle. You need to sketch a picture, but your clues are up here and what we've talked about. Are you supposed to try it on your own? So if you have a triangle with 30, 60, 90 angle measures, what kind of triangle would it be? A right triangle. And that would be because of this 90 degrees. Did anyone say scaling? Can you get the 5-star green past me? Did anyone say scaling at all? Yeah. Scaling is also correct because if it's 30, 60, 90, then are any of the sides going to match? No, the angles indicate how many sides match, okay? None of the angles match, so none of the sides match. So you could say scaling as well. But the most correct answer is definitely that it's a right triangle. All right? If you have a triangle measuring 2, 2, 2, what would that be? Yeah, all of the sides are equal. So it's a 2, 2, 2 triangle. You could also say equiangular as well, because if the sides are equal, then the angles are equal. But we're going off of the info that they first present. All right, what if it's a angle measures 60, 60, 60? Equiangular. What if the sides measure 6, 3, 6? Notice that these two match, which tells me it's an isosceles triangle. What if the sides measure 5, 7, and 9? Scaling? Can more people, you're doing awesome by the way, you're rocking it. Can more of y'all try to pitch in? She's carrying the whole weight. What if the angles measure 20, 125, and 35? Notice right here, this angle is more than 90, so that means it's an obtuse triangle. Okay, look at number 7. It says, can a right triangle be obtuse? Don't answer out loud. Don't answer out loud. Take a second. Try to sketch a picture of a right triangle with an obtuse angle in it. And then think about what we've talked about and learned so far and answer the questions, yes or no. Can a right triangle also be obtuse? All right, what'd you get? Did you say yes or no? You said no? Anybody else want to pitch in their answer? You said no? Okay? And you're right. What's the math behind why an obtuse right triangle won't work? What's the math behind it? Like there's a mathematical argument like this is why it will not work. It has to do with the sum of the angles. Yes. Okay. And how many angles is that so far? And then you would need, and they would add 2. And what's the problem? It's already busted, right? If you have a 90-degree angle, and then you have an obtuse angle, meaning more than 90, you've already busted the triangle. There's not enough for the third angle. So the answer is no, it's not possible. And it's because of the sum of the angles of a triangle. All right, let's look at these down here. 14, 15, 16. Yes, I know it's not counting in order. I definitely forgot to fix the numbers. I cut and pasted these and forgot to fix the numbers. Just go with it. All right, so number 14, it says find the angle measures and then classify it by its angles. We don't have to classify it by its angles. Let's just find x. So look at 14. Don't get lost in what we've learned today. Think back to the other day when we learned the sum of the angles of a triangle is always what? 180. Learn to look for shortcuts in that if this is 60 and this is 60, then x would have to be 60. But if you don't see that shortcut because of the equilateral and equiangular concept, you could still say, I know the total is 180. I'd subtract off 60 and 60, and I'd be left with 60. So you can still get there using the total as 180. All right, 15. We're finding x. One technique is to set up the entire problem as adding the 3 angles to equal what? 180. That technique works. There's nothing wrong with that technique. It just takes longer. That is the only downfall. If you like the subtraction method, let me show you that technique. You know the total's 180. You go to what you know and subtract it off. So 180 minus 60 is 120. Now I have 2 angles left. I don't know both of them, like either one of them. So I would make a note to myself, like between here and here is 120 total. And there's my equation. So x plus 3x has to equal 120. That's a shorter equation with smaller numbers that uses the subtraction method, and you will get the same answer. Okay? In fact, if you notice right here, if I just took this 60 and subtracted off, I would end up with the exact equation I have over there. So the subtraction method basically cuts out that first step. Let's see, 120 divided by 4, what'd you get? 30? $16 is the, what I call it? What was the nickname I gave it? Bougie. I said it's the bougie angle because it's silly that they gave a theorem to something that should just be deductive reasoning. If I'm trying to find this angle, it is on the outside. This is exterior, okay? So the bougie angle is you find the 2 angles on the inside of the triangle that are not next to it, and you add them up. So x would be 64 plus 70. What do you get? You want to label it, this is the bougie angle. go to the back. Look at 21 through 26. Oh my word, these numberings. Look at 21 through 26. You have this picture over here, right? This is, I love this because this is a problem-solving question. Like, it's not just one thing you're finding, and also it's a domino effect. As you start to find stuff, if you'll label your picture as you find it, the whole problem just kind of falls into place. You know this is 40. You know this is 20. What else do I know?
90.
I got a 90 here.
90.
There's a 90 here. You also have what vocab word from last Thursday? Angle pairs worksheet. What angles are in that picture? What type of angles? It's on page 14. Vertical angles. You have vertical angles in here. Anytime two lines cross, it doesn't have to be a line, it can be segments. Anytime two lines cross, bam, you have vertical angles. Think of an opposite-ended, like a double-sided flashlight. So what do I know about angle 1? There you go. And what do I know about angle 2? There you go. So if I find in either one of those, I can state the other one. There's another vocab word here from page 14. Can you tell me the relationship of angles 1 and 2? 1 and 2. Keep going. Keep thinking. Keep talking. 1 and 2. It's a vocab word from your angle pairs worksheet, page 14. Supplementary. What does that mean they do? They add to equal 180. I'm going to come over here and draw it over here so that it's not crowded. This is angle 1 and this is angle 2. Right? You see how I kind of just zoomed that out? Do you notice how they make a straight line? Remember linear pair? Remember that phrase? Linear pair means they make a straight line. This is a linear pair, which means that they're going to add up to equal what? 180. Are 1 and 2 the only linear pair in this picture? No, there's several. Name another linear pair. 2 and 3? Yes. 1 and 4? Yes. There's one more. 3 and 4. Think of them as puzzle pieces that come together and form that straight line. Okay? All right, so take a second. These should be nice, pretty numbers. There's no decimals. And the angles we do know are 40 and 20, so you could probably do some of this in your head. Take a second and find the measure of the angles that it asks for. If you will label your picture as you go, it makes the problem easier. Okay, we'll call on people if people don't start chipping in. So angle 1, 50 degrees. Angle 2. Okay, hold on, let's look. I heard 50 and I heard 130. 2. You're good. Oh, you went down. Sorry. I guess that would make sense. All right. So angle 2 is what, y'all? 130. What about angle 3? Good. What about 4? All right. What about 5? 40. 3 is, yep. All right. Angle 6. 30. Okay, now we're to some practice problems. here's where we get into where I was saying turn it like a rooftop if it's isosceles. Okay, so please remember that. Maybe make a note. ISOS, isosceles. All right. Turn like a rooftop. Turn it like a rooftop. So number 7. What type of triangle is it? That's isosceles. Find the sides that are congruent, then go to the angles that are congruent. The base angles are congruent, so what's x? 55 degrees. Make those marks, the congruent marks, and I promise it's going to help you. All right, number 8. Kind of hard to read. Not sure if that's 66 or 68. Can you tell on yours? Is it 68 on yours? All right, we'll go with it. Is this turned like a rooftop? No, but it is perfectly upside down, right? So if you could think upside down, or you could take your paper, turn it upside down, find the top of the roof. This is the top. There's the congruent sides. So what do I need to mark? Base angles, or what? They're congruent. So find the base angles. So what's x? 68. You think that there's really not a lot of thinking involved, but it is. You have to look at it and recognize it's isosceles, turn it like a rooftop, find the base angles, they're congruent. So there's a little bit of thinking involved even when you don't realize it. Number 9, what type of triangle is it? It's a right. There's one more word. It's a right isosceles triangle. So this is 90 here. This is my congruent legs. Take your paper and turn your paper so that the triangle's like a rooftop. Then mark the congruent angles. Where are they? They're down at the bottom if you turned it like a rooftop. Yes, angles E and D. You might think we don't have enough info here to answer this question, but we actually do. You've got the square measures 90, so we know one angle. We also know, what about triangles and the angles? They all 3 add to equal 180, right? And what else do we know in the picture? We have congruent base angles. So if this is x here, this is x, then what's this? X, right? So you can set up your equation 2 different ways. The long way is angle plus angle plus angle equals what? 180. That definitely works. What would that look like if I was to write it out? Somebody tell me. Angle plus angle plus angle equals 180. What would it look like? I'm going to take the 2x and split it so people know where it came from, just in case. So that's one way. That way works. There's nothing wrong with that. What's another way? Yes. Very good. So this measures what, y'all? This is 90. That leaves how much left in the triangle? If we do the subtraction method, we got 180. We take off 90. That leaves me with 90. So I have 90 degrees between these 2 angles, which have to be what? They have to be equal to each other. So what do I do with that 90? Divide it by 2. And you get that x is 45. That is a more intuitive way to get there. If you don't see it that way yet, the goal is eventually you will see it that way. For now, the angle plus angle plus angle equals 180. That works too, okay? All right, now we're looking at number 10. We're using algebra to find the value of x. What do you notice in number 10? What's my given info? I've got base angles marked congruent. If I have base angles congruent, then I have what secret type of triangle in front of me? Starts with an I. It's an isosceles triangle. Turn it like a rooftop to find your congruent legs. So it's completely upside down. Turn your paper right side up, or upside, whatever. So like this is the top of the triangle, right? So here are your congruent legs, which means now I know what my equation is. This crap has to equal 11. That's your equation. That's what you write, set up, solve, cut, print, run the tape. So x plus 4 has to equal 11. So x would be 7. All right, you try 11, 12, and 13. They're the same thing. 11, 12, and 13. So no Delta Math assignment tonight. Instead, I would like you to finish this. I'm going to fix the image. In case you're worried you can't read the number, I'm going to post it to Google Classroom. Go in there and check, okay? I'm going to make sure we all can see clearly what the number is.